Okay, here's our video today. How spiders adjust web design to noise. And we're going to talk about urban noise. So those little arachnids, well, they're engineers. They're acoustic engineers. So there have been many studies, and they show, especially with the orb spider, but with other spiders, that they perceive noise. They can't hear, right? They can feel through their legs. They don't hear like we hear, but they can perceive acoustics through their legs. So we're not the only acoustic engineers, and they will design their webs based on their environment. So simply urban city spiders, like Spider-Man, right, will adjust how they make their webs to dampen human noise, or just any noise that you can get in the city. And you can get a lot of noise in the city, like traffic, music, conversations, barking dogs, Aunt Sally, snoring, whoever. So in urban areas, they build their nests. And here's some things that they do. Make sure our pen works on this one. Find my pen today. I'm going to use red. Spider-Man has a red. Doesn't he wear red? So they build their nests higher up in urban environments. Higher up. Like rural spiders will, because of vegetation, they will build their nests lower. Right? So they build them higher up, and they make them, actually let's change the color. Let's go for yellow. They will make them denser, thicker, denser and smaller. Maybe we'll switch the color again. Maybe we'll try that color there. They also will make them more vertical. And all this will be to adjust the frequency range. So let's get a clean page here. So this is how Spider-Man might build his web in the city environment. So just in general, you can see how the webs are thicker. Obviously, we're not going to see a spider this big. That'll be a movie. So let's see if my pen's working again. So if we talk about the rural, let's look at rural spiders. Suburban spiders, commuters, little arachnids. They will build their nets lower to the ground. And again, you can see rural spiders sometimes higher up, but they're lower to the ground in the most cases because of vegetation, right? They're going to be more inclined and bigger. So they're trying to get as much insects as possible. And they're also building their nests with less frequency adjustments. And I'll go over that. So you think of spider's prey. This is the rural. Let's put it over here. Think of a spider's prey. Of course, insects and so forth. So the insects, put them over here, they produce low frequency. So with rural spiders, when it's an insect, because of less noise, they don't have to dampen out high frequency. So on web impact, you can get anywhere between 20 hertz to 1 kilohertz. So if you think about urban noise, we'll put out urban noise over here. Think about a car horn. A car horn can go up. Let's put a car horn over here. A car horn could reach 1 kilohertz. Low music could be 30 kilohertz and so forth. So what the urban spiders have to do is that because of those high frequencies, they don't hear, well, again, they don't hear, they feel. They're not feeling the low frequencies. The high frequencies are damping out the low frequencies. So they have to adjust their webs for it. And hertz, by the way, besides the car company, hertz, we'll put them right there, hertz, is just a way of measuring. It's a unit of frequency. It's a unit of frequency. All right, and the human ear could hear anywhere between 20 hertz, that's very low, low bass, to about 20 kilohertz. And as you get older, you don't hear that high of frequencies. So if you think about older adults, and we're talking about in their 40s or maybe even in their 30s, they start to lose this high frequency range. So, for example, at 16 hertz, that could be the limit for older adults. Anyway, moving on. So again, high frequencies that you get in the city, they can stress the spiders out, and they can't feel. Remember, they can't hear. They can't even smell like we do, but they can actually pick up pheromones, like for mating and so forth. And even, there are certain chemical signals in urban environments that could affect spiders also. But this is just a sound video. So those high frequencies will be amplified on the web. Now over here we're looking at a urban spider. As you can see, it's much bigger. It's not as thick because it's built for low frequencies. So what the urban spiders will do is they'll adjust their silk. So let's write that down. Put it over here. So for urban spiders, those city spiders, they'll adjust the silk. So they can adjust their silk. The spider web itself will be denser. And when they adjust their silk, and they can do it with the right properties, they can feel, again, they don't hear, they can feel those lower frequencies better. They can, if it's denser, and if they adjust the silk properties. And thickness can be more effective, again, for low frequencies. Think of a bass string. See how thick a bass string is when you're playing bass. So the design of the web for urban design, urban spider design. So for urban design, just in general, they should be smaller, thicker, denser. The silk properties need to be different. Because, again, the smaller it is, they can reduce vibrations so the spiders can detect those lower frequencies. And again, they should be more vertical. It's a key one, vertical. To grab in more light rays. Because again, insects are attracted to light. If you think about a vertical web, vertical web coming in like this, and the rays, light rays coming in at different angles at different times of the day will illuminate the web, especially with the different silk properties. So rural spiders or suburban spiders, maybe the suburban spiders are in between, but for rural spiders, they don't have to worry about dampening high frequencies often, so they don't worry about having it vertical, and they could make it vertical. You can see vertical webs and so forth, but they try to make it lower to the ground, like I said before, because that's where the vegetation is, and you want to catch as many insects as you can for survival. All right, that's our video today.